Okay. Okay, let's start with the feedback from the last class. Uh, if f prime r exists, then the limit is equal with the function at r. Okay, the answer is true. This is because uh, we remember that when we have the limit, okay, we can prove that this is actually exists. Okay, the limit exists, and the limit, yeah, this limit exists, and then it's equal with some value, and that value is also equal with when we evaluate the functions at r, which means we can say that this is f is continuous, right? Okay, so from what we have done before, we say that if we can differentiate or we can derive f, or if f is if f is differentiable, meaning we can say that also the f prime exists, then it must be continuous. Okay, so that means this is true. Okay, this is the basic concept on how we are looking on derivative and why in certain functions we can say that, oh, maybe the derivative, or maybe in some area like in the absolute value, like in the f of x equal absolute value of x, uh, not differentiable at x equals 0, but the rest of the x all continuous and all can be differentiated, right? Okay, let's move on. Okay, this one. Uh, so A, B, C, and D, all uh, all functions here need to be matched with the derivative at 1, 2, 3, and 4, right? Okay. So first thing you need to do is you need to look at the gradient at which the gradient is 0, the slope is 0, or we can look for the horizontal tangent. Okay, let's start with the first one here. That is the 0, 1, right? We can also look at this one and also this. For B, we can also look at the gradient is a constant, right? There's no change in the gradient. So we can also look at which one that has a constant value. It's 4, right? So we can directly go for B is 4. And the rest, we need to make sure that when we evaluate at some point here, or maybe here at 0, we need to make sure that it's crossing uh, 0 at the gradient, at the derivative. Okay. So for example, for number A, it has, let's say, AB for gradient 0, and the only one that has precisely 2, 0 is just this one, right? The other one is only 1. This is 3. 1, 2, 3, right? So probably that is our answer. So by looking at these two answers only, we can say that our answer will be this answer. Okay, and we can also look at the other, and same thing. We can check. This is crossing 0 at the middle here, the middle, right? And also the other as well. Like this one is has 3, 0. This is also has 3, 3, 3, 0. Okay. Okay, that's just a review for last feedback time. Now I will go to uh, it's the exponential function. Okay, exponential, or you may remember, it's called exponential because it's increased significantly, significantly faster. And from this function also, we know that there will be some irrational number called E, or Euler number, that actually some scientists, physicists, mathematicians, they got this ratio number of E uh, from several cases. For example, from the when they calculated the population, or they solved some mathematical problem. If I have time, I will maybe going into more detail about this exponential function. But at least from there, uh, people get to know about E, or the Euler number. Okay, let's start with, before we go to the E, let's start with the functions of any B is for base. Okay, so in exponential, that you have base at this. Okay, we call this base, and also the same term in logarithm. We will go to logarithm later. So let's say we have a functions of b with the power of x. Okay. Okay. Let's try to compute this functions using our definition of derivative. Okay. So let me write all the necessary and let's exchange this all to with the function b x plus h minus b with the power of x. Okay. Okay, let's simplify. And then we can have this expression. Okay. Now, b with the power of x is a component that doesn't need h, right? So we can factor out the b with the power of x because it's independent of h, right? So factor this outside. So we will get, okay, you can also see, okay, if we plug in 0, then this is actually the same as the limit here, right? Because uh, b with power of 0 is 1, right? So we can say that this is actually okay. And then how do we approach this and finding the uh, the solution for our derivative here? Okay, we can say, let's start with this expression here. Okay, we can start with some h. Start with maybe h that close to 0. Start with 0.1 and how it's going to look like, and maybe you start with some b. Okay, let's say we can have b equal to, or any number. Okay, so let's start with some number here. So we put in 0.1, and if you try also, it will get around this 0.71773. And then if you put in 0.01, it will get around 69, yeah, 55 something. And then maybe 0.0001. It will go through 0.69317, and it will go closer to some number that start with 0.69 something. Okay, so probably that will be our results for a b equal to. Okay, and if we try with another b, let's say b equals 3, this will result with 1.1612 something something. And if you have 0.01, you will have 1.10467. And if you have 0.0001, you have 1.09867. And if you are adding more zero, it has the closer number to 1.09 something. Okay. Now from these two numbers, if you notice, okay, the result is 0.69 and 1.09, right? So probably somewhere in between, there will be some result that has 1. Okay. So if we put some number p between 2 and 3, there will be some resulting 1. The final result will be 1. Okay. So that b actually, okay, that b is actually is our e. Okay. So our e is when the limit, let's say e h minus 1, h, this is equal 1. Okay. And we may, for now, we may approve this definition as our e. Okay. And then what is the number, this number 0.69 and 1.09? This is actually ln2, and this is ln3. Okay, now if you look the functions, okay, and maybe we can imagine we have uh, this 2 with power of x and 3 with power of x. We have e in between those two. Okay, so e is around 2.71 something. and it's really long number. And you will see that it has, if you look at the slope, it starts slowly, but then after it crossing the y equal 1 here, it goes faster, increase really fast. Okay, since the definition of E is this, then f prime x when B is actually E of Bx, then uh, then f prime x is just e to the x. So it will be same thing as the original functions, right? If we look at the graph here, let's say we have 1.0. Let me erase this part. Let's say we have 1.0. Maybe here is 10. Okay. If we are looking at this, this is actually y at um, 10 is e, right? Y prime, the tangent at uh, 10 also e. So it's having e, and then this is e. Maybe this is e, e, and this is the m is e also. So one of the unique property of the e, when you are deriving e with the power of x, it will be the original, the same as original function. Actually, there's another term to set e. Um, this is another term to set that this is also e. Uh, Usually, this is in finance, uh, from the compound and interest. I think I will not go deeper for this one. I think for calculus, okay, I think you can just use the first definition, this one, okay, this definition. Maybe later in calculus 2, we will learn more of E, okay, and how we can also elaborate E in more details. Okay, any questions first? Yes. Hmm. So basically, people are looking for number that is making this equal 1, and they found that number e, when they put here, it is actually 1. So they also try to figure out some table here and then try to finding some value. So they are actually also, yeah, using trial and error for every values that they had, and they want to make this actually 1. Okay. I think there's another way to look at, like for example, from here you can also get e, and also they try to put some value for some value n, and then when they are compute, it's also e. I think there's also another examples like populations, like how we increase the number of populations. They are increasing in exponentials, right? Like people from uh, 100 years ago, and then every 10 years or maybe every several years, they will increase exponentially, and the ratio on that population is also e. Okay. And when we are talking about e, we can also talking about uh, the log, okay? The logarithm. Okay? We are using the logarithm to make our how to say that, our scale measurable. Like for example, why we are using log in our calculation, because we are seeing the database is the number is huge, like maybe 10, 100, 1000, and you can see that, okay, maybe we can have some measurable that are equal with that power, and then they made, okay, we can have a base of 10, so we can say log 10 is 1, log 100 is 2. So when they put into the graph, or when they analyze, it's much more easier, right? So e, when you're dealing with log, it's become ln, right, with the base of e. So if you remember, this is log, right? Usually this is terms for the base, also same terms, right? And when b is e, we can say that this is actually called ln. So ln means log with base e. Okay, and we call the n for the ln is logarithmic, or log natural. So that means it's the ratio of, or we can say the numbers that came from nature. Because when we deal with nature, when we observe, we came out with the number of e. Okay. Okay. But I think for calculus, for calculus one, I think just this definition for calculus one is enough. Mostly the case or problems in the textbook, you can always refer to the definition of from this calculus one definition. Okay. Let's look at this is just what I said in the previous slides. So definition of the number e, and also maybe write some uh, formal definitions like that. Okay. Now, if you look at this example here, at what point on the curve y to the x is the tangent line parallel to y equal to x? So in the calculus one, especially this chapter 3, there will be a lot of questions asking about the tangent line, finding the equation, maybe finding the point of the tangent line. So uh, the first thing you need to see at the question is you need to make sure that you know uh, what you need to find. First is there will be a tangent line, and it's parallel to another equation, which is y equal to x. So if we look at the graph here, it's illustrate what the problem is. We have the equation y equal to x, okay, and then we have, yeah, this is actually the answer, but let's say this is the point that is in our observation, our tangent line, and the red color will be the tangent line itself. Okay? So you'll see that the line is parallel, the two lines is parallel, right? So which means if we have two slope, it is equal, right? And for the tangent line, to find the slope of tangent line, we can just look at the derivative, the first derivative, and then let's say we will compute at x equal a. That means we will have e to the a, okay? And then we know that the slope is the same. Slope is the same. Then the y prime is actually the same as 2. We can solve this, and this will be our equations now. So we can get a is actually ln2. Now when a is ln2, y when it is ln2, this will be e and then ln2, which is 2. So for uh, for anyone who are not really familiar with the log exponent, I think you can try to review that concept if you maybe not remembering the basic concept of exponent or log. Okay, but the point is ln2 2, which is in here. Okay. Okay. Now that is the exponential function. Okay. The next sections, we're going to elaborate more. I think you're already familiar. It is about the product rule and the quotient rule. So maybe just a little bit review, and let's see how uh, we can find some proof, or maybe uh, some examples. And if we have time, maybe we can finish at the trigonometric functions, especially the sine x. Okay, let's start with the product rule. Okay, uh, I will start with the conclusion first. So this is the product rule, and let me explain to you and how the functions it's becoming like this. Okay, so f and g, of course, you need to make sure that both functions are differentiable. And if you have two differentiable functions and they are in multiplications, f of x and then multiply with the g of x, then you can have this uh, formula. Okay, or if you want to simplify this, you can say you can have this Okay, now let's elaborate this product rule. Okay, but first we are going to have another functions that are actually this is fg, but I will use the big F. Okay, and start with the definition. All right. Now, how to fix or how to simplify this a little bit. So first, if you look at the uh, if we look at the limit here, okay, if you can make somehow the gx, like for example gx plus h, if you can make this happen, inside these functions, then we can simplify and 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 we can get the final results. So the idea is we need to add and subtract uh, some formula or some expression. Let's say we can add and subtract. So we add and subtract this expression and see when whether we can simplify the equation or not. Okay. Okay, so we can write. So plus and minus. Okay. Now we have these expressions, and we can now be grouping all these uh, expressions. So we can group the grouping the fx plus h and gx. If you see the fx plus h, fx plus h, we can factor out, and we can factor out this, and you will see that it has fx plus h minus f of x, and it has gx plus h minus g of x, and we may have our final result with some derivative inside these expressions. So let's write our factorizations. So limit h 0. And let me write this is fx plus h oh sorry, this should be with this minus, right, and this should be with this, okay, the group. The so this one should be with the minus one, so this should be minus g of x, and plus, okay. Now let's separate this functions become two functions, become two expressions. This limit become two limit expressions. First is this, and then we may write another one here, and then plus limit. Okay, now we may have uh, our expressions here, and we can compute. Okay, we can compute the limit. This will be the f prime. This is just g of x. This will be f of x and g prime of x. If you have the textbook, you may have seen the different different process, but it's end with the same result, same conclusion. Okay, this is okay for whole page. Okay, now we have our product rule, and my suggestions. Okay, this is just my suggestions. If you have the product rule, uh, my preference is always start with f prime x, and then g of x, and then plus g prime of x, and then f of x. Just my preference. You can start with g prime f and plus f prime g, and it's the same. Okay, but my preference is, because we will see with the quotient rule, it's to help you to get all the idea together. Okay, before we continue, we'll share one more time um, the QR code. So let me share with you the QR code first, and then okay, if you haven't scanned the QR code for the online students, you can scan the QR code. Oh, wait. I need to bring back to here first, and then share again, and then bring back to here. I don't know why. Okay. Hey, I think we can uh, continue a little bit. Okay, the second is the quotient rule. Okay, now this is the expression for the quotient rule. You can also write in terms of uh, the same thing. And then similar with the product rule, we can also try to prove using the limit definition. Okay. So start with some f, and we can start with the our f over g, okay, for the quotient expression, and then we can start writing the limit definition for the first derivative. Okay, we can start with that, and then similar thing. we can add and then subtract some expression that probably with that expression we can get our derivative. Okay, so we can add, subtract this expression, because if we have this expression and we can factorize and we will get some derivative out of it, and then maybe we can simplify our limit. So let's write down let's subtract and add. Okay. And then grouping gx and f of x. And you may notice that when you group this, let's say just this, so you can look that this is the derivative. And then the other one is minus. Okay. Limit. Okay. Or maybe you can maybe directly get the limit from here. This is limit. Also, this is limit. And then don't forget we still have the bottom equations. Okay, then evaluate. Okay. Oh wait, the h should be gone because it's going back to the top equations. So evaluate. Uh, this will be g of x, f prime x minus f of x. This is g of x. Or maybe you can start with f prime x, x. And maybe make it similar with the first product rule. And yeah. And as we can have these two expressions, the product rule, the quotient rule, to solve some of complex functions. Okay. Okay, maybe I will give you maybe one example, and maybe the rest of the example I will give to the TA and maybe next Friday class. Because mostly in chapter 3, because we are the discussions is more about rules and some set of uh, formula in terms of derivative. There will be I think a lot of examples, and maybe I'll give you maybe 8 or 9 questions to do in practice in the homework. Uh, yeah, I think uh, to get familiar with the rules, you need to get a lot of practice. Okay, but I think if you are already familiar, I think it should be okay. Should be okay. Oh, by the way, I've assigned the quiz in the Google Classroom, right? I think some of you already joined. I forgot to mention, uh, but if you already take the quiz, that's okay. Please write your student ID. Don't forget to write student ID for the quiz. Okay. And if you have some difficulty, just let me know. Okay. Because I will open that link. So the once you are inside, you need to finish the quiz. If you are close to platform and you want to log in, maybe you will not be able to log in again because I set the attempts to be only once. Okay, but please let me know if you have that trouble because this is just the starter, the first quiz doing with that platform. So maybe some of you are still not familiar with. Each question in the quiz will have a timer. There will be like a moving bar in the top of the. If you're opening your laptop, there will be a moving bar. If the bar is getting, it will move from right to left. When it's reached left and you're still not able to answer, it will skip and then you will get another question. So please be careful. So some questions will have like maybe just like slow, and then some will be very fast. It means that for direct questions asking, maybe you have there will be a statement and you need to answer a true or false. I think that will be fast because you don't need to calculate. So at least the minimum timer will be 30 seconds, 45 seconds. I think that should be enough. It's like when we are doing in our feedback time. Okay. Okay. Let's get back to this example here. But really before the example, let me just remind you some of functions that already been delivered in our discussion before. So some of differentiation formula here, and I think this is very basic, and I think in your high school probably you already learn most of these functions, right? I think all of these functions are already in high school, right? So this is just a review. Let me give you an example. Um, let me check. Okay, find the equation of tangent line and normal line. So you need to find two lines, tangent line and normal line, to curve okay, that's just the question. So you need to define two equation of line, tangent and normal. Oh, I just read your question, Jordan. I will send the meeting record today. Yes, yes. I will send maybe afternoon, probably, because it we need to wait some process in the drive, in the Google Drive, and then after it finished, I will upload to the Moodle. Okay, the key for answering most of the questions for tangent line or normal line is finding the first derivative. Okay, that's the first thing you need to keep in mind. So every tangent line, so tangent means the slope is y prime. Okay, so we need to find y prime because it's a rational function. We can maybe approach with the quotient rule. And let me write one by one. Maybe some of you still not uh, really maybe familiar. Let me write the steps. So imagine this is f and g from this curve of y, and this will be f prime g, and this is g prime, this is f, this is g squared, right? Okay. Now we are all set with the first derivative. Now let's derive one by one. Okay, derivative of square root of x. Let me write here. This should be this, right? If you are maybe not confident, if you're not confident, or you need to confirm, you can write through this, okay? And you can have half x, half minus 1, or this will be x, or this will be, or, okay? So I think some of you maybe not really uh, familiar, or you cannot really calculate really fast. Okay, so this is the steps. Okay, if you want to know more, but I think along the way, I hope you get uh, eventually familiar with the whole formula here. Okay, let us write here. This will be one, and this will be oh, no. Okay. Now the question is just asking the uh, line equations, right? Which means we are only consider the slope. Okay, the slope at the point. What's the point? What at x is at x equal 1, right? So the slope at x equal 1. So we can just try to look at the final result, plug in x equal 1. 1 plus 1 is 2, 2 squared is 4. So I will have 1 minus 2 minus 1, so it should be minus 1 over 4. So this is our slope. Okay, but this is not our final answer. We have to find the line. So first, the tangent line, the slope is negative 1 over 4. tangent line at 1.5. This is okay, and you can finish the equations and making the plus 2/4, 3/4. And the other one is the normal line. The gradient is 4, okay, for normal line. Remember normal line, so if this is a tangent line, this will be the normal line. So, okay, or so you need to reciprocate and then take the opposite sign. Okay. So this is your two line here. Okay. Any questions from the online students? Any questions? Okay. Sometimes, like this question here is asking the tangent line and normal line, and then you see you have the formula you try to derive. Sometimes students lose a focus, okay, losing a focus. So you get into here, okay, and then you try to simplify this and make it maybe more simple. But if you are limited by time, I don't think that's really necessary. If you are thinking that maybe you can just plug in you can evaluate just the point and then you can get the answer. And I think that will be, I think, faster. But some students maybe they are losing focus and then they keep trying to maybe simplify this. And it's happened not only with this function here, maybe in a more complicated one. But some students maybe they still think that okay, I need to simplify this, and they lose focus on what is the purpose for the questions. Is it to find the line equation or what, right? Or the equation just finding the first derivative and make it into certain formula. You need to change the formula, blah blah blah, right? So you need to focus on the goal. Focus on the goal in the questions. Okay. Yeah, just to keep in mind. Yes. Yeah, normal line is. I'm not sure if you are familiar with the in physics or in math in general. Uh, you see there is a concept of vectors, right? Vectors, right? So in vectors, if you have something called a normal vectors, the normal vectors mean it is has the uh, this angle here, which is 90-degree, okay, and we can call that it's a normal to this line, or if you have the plane or maybe yeah surface here. If you want to know what is the normal vectors, that means the vectors that is come out from the surface or from the plane or from the line that is actually perpendicular or have 90-degree. Okay? So when you have a normal line, meaning the normal uh, it will refer to this line, and it has this 90 degree. So the normal line is a line that is come out from plane, from surface, and it has the 90-degree angle to the surface, to that surface. Okay. Okay, I think we can move to trigonometric functions, and then so I will one by one. I will solve uh, some proof with limit definitions. Okay, and then after we have like several tools in our derivative, we can have more exercise and practice. And I think I can also give you this week for some questions. Maybe just seven, maybe eight questions. Okay, let me move my slides here, and let's start with our sine x. Um, if we remember the trigonometric functions, okay, okay, let's just imagine that this is our sine x. If we look at the gradient, then we can say that we need to check all the slope at which the sine x will have horizontal tangent. And this is actually a line here. Okay. And this is actually a line here. So if we are going to check with the derivative, I will move this to here. And maybe using different colors. So it will cross here. It's increasing here, positive, right? And this is decreasing, and then it's negative, still negative. And this will be positive, right? This will be negative. Okay. Okay, from the first one here, we have a positive increasing, but when it's reaching 0, so from plus to 0, it's going to be decreasing, right? So it should be the curve should be going down. So it should be going down here, right? And then it's negative. Uh, it's decreasing from 0 to negative until certain point, and then after this point here, it's a little bit increasing until 0, right? So from zero, from negative to 0. So if we look at that, this is and it's going to 0, right? Going to 0, and it is going to increase. And at a certain point here, it changes from 0 to positive. This increase, but here it's decrease, but still positive. So we can say that this is going to be like this. And I think we get the pattern. And you can use that pattern. Okay. So that's how you are looking at the functions and the derivative. Okay. And in particular, for the sine x. Okay. And if you look at the graph itself for the derivative, you know that this is a functions, another trigonometric function, which is cosine x, right? So from here, you can get some intuitive definitions from the graph that the derivative is cosine x. Okay, but let's see whether we can try to prove using our limit definition. Okay, let the f of x is equal with sine x, then f prime x is we start from the basic formula, exchange with the functions. Okay. Now you may need some skills in trigonometric to solve this sine x plus h, to expand that sine x plus h. I hope still remember. So sine will be sine x cos h, right? Plus, right? Okay. And then minus sine x, divide the whole thing by h. Okay. Okay. Let's factor out sine x and maybe separate, become two limit functions. So the first one is this sine x cos h minus 1, and then plus oh separate, become two limit functions. Okay. Okay, now how to solve this? Okay, first, remember that at the early limit, or maybe several weeks ago, we already make some proof by squeeze theorem that this sine x over x is equal 1. Okay? And the whole thing that I told about the L'Hopital rules, right? That you cannot use L'Hopital rule to solve this limit because this is the definition. So it's come out on the very limit definition here that you have this, right? You have sine h over h that you need to solve through another method, which is the squeeze theorem. And we already proved the squeeze theorem, and we say that sine x over x equal 1. And I think I also give you the graph. If you draw the graph on GeoGebra, it is precisely the limit is 1. Okay. Okay. Now the other things, I forget if I already told you or not, but let me just solve this limit. Okay. So let's solve this limit. Now this will be the same thing as this, right? So we can say that this is uh, minus sine squared, and I will make sine becomes sine x. This whole thing is -1, but this is making it 0. So the whole thing becomes 0. Okay. And then we can put all these informations inside the derivative. Inside the derivative, here we know that this will be just sine x. Multiply with this part here is 0 plus this part cos x, and the sine h over h will be 1. So in the conclusion here, we get d dx of sine x is equal to cosine x. Okay, that's the trigonometric function sine x. Okay, let me write several important trigonometric functions that you can also derive from the sine x. Okay? From the sine x, so let me write the whole thing. Sine x become cosine x. Okay? And by the way, do you know why cos is named cos and sine named as sine? Why? Do you know why? Great. Have you heard sinus in your nose? You call this a sinus. So if you had, it's called the sinusitis. It means that you have some ache in. It has a curve inside your nose, a curve, and when it is having inflammations and maybe really that bad, some doctors call it's you have sinusitis, which means that you are always sneezing every time. When you have cold, when you have it, you're always uh, sneezing. And the sign is because your nose has a curve. Okay, but the idea of sign is basically came from uh, you have a bow and like an archer, right? This this curve for the bow, like you have this bow here. This is called sign. It's from India, and then it's translated into modern mathematics, and it is becoming sign. And when you have like this, oh, it is a curve, and then people say, okay, it's sine. And cosine is because it's cosine. It's complementary of sine. Because cosine basically you just shift your graph, right? So it's just complementary to sine. Okay. Okay, so for the cosine, you can use the limit definition if you want more. And remember if you have cos x plus h, what is the formula, but the result will be minus sine x, right? Because it has minus inside the cos x plus h, right? And then you also have another important one is the tangent. Do you remember it is the secant squared x? How to define this is from quotient rule, and then eventually you will get the result. And then the other one is secant x. This will be secant x, tangent x. Okay. I think they just by these four functions, trigonometric functions, sine, okay, cosine, tangent, and secant. I think that's enough. Okay, I think that's enough. The other one, like the cosecant and cotangent, not too necessary because that is just 1 over sine and the 1 over tangent, and you can get the idea and then maybe derive one by one. And still you get the results the same as this. I think I will stop here, okay, for the trigonometric, and then we can have more exercise and practice later on, and maybe we can start this Thursday with the chain rule. So let's do the feedback time. Okay. Okay, let me stop this and let me make it small. Okay. All right, everyone. So for students in the class, students online, um, you can start to log in using the QR code or using the website and type in the code. Okay, so uh, in the in the uh, in the early introductions today, so sorry for a very technical problem because I reset my password for some account, especially for the NTSC account. So I need to rearrange the setup. Okay. 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 I think we can start. And I think if you're like doing an activity with your friends, with your maybe colleagues, if you want to look for how to engage the students, like I was always like when I teach, I see like some faces of the students. It seems that they understand. Okay, but I'm not really sure, right? I'm not really sure. So I need to like take some feedbacks or maybe uh, how they understand, like with this simple concept, and maybe asking like, what is your suggestions or maybe your question if you need help. So I can have that as well. Okay, let's start with 3, 2, 1. Okay, I hope the time is enough, around 40 seconds. 40 seconds. Okay, 15, 14. Okay, 10, 9. Okay, 5, 4, 3, 2, 1. Okay, finish. Okay, it's 7. How many correct? I think a lot of you guys get the correct answer. Let's see who get the, yeah, yeah, only 5. Yeah, 5 people in the class. Do you get it or not? Oh, you get it? Okay, good. Okay, let's go one more. Question 2, 3, 2, 1. Okay, let's start. Now answer fast to get more points. Okay, we just uh, solve the similar questions. I hope you still remember. I give you 1 minute 5 seconds, so I hope you can get it correct. 50 seconds. There will be 2 answer actually, but I just put the one correct here. But you need to find which one is correct. Okay, 28, 27, 26, 5, 4. Okay. Yeah, I think this should be under 1 minute. I think you can if you are not making mistake. I think under 1 minute is I think enough. 5, 4. Okay. Okay, just pick random answer. Okay, time's up. Oh, okay. Okay. 7 students got correct. Okay. Is Jimmy here? No. Jimmy? Okay. Congratulations. Congratulations. How many quiz you win? 2, 3? I think 2, right? Or 3? 2, right? Okay. Congratulations. Okay, if you get 3, I will give you some bonus gift. Okay. Uh, lastly, just write some of your feedbacks. Maybe you have difficulty on some maybe concept learning or maybe some suggestions. Anything you can write, questions or maybe suggestions. Or maybe you tried the quiz and maybe you feel difficult, or maybe you feel maybe you need to maybe I need to have some um, more evaluations for the quiz, because I set the quiz to have timer on each question. It is just to make sure that you are focused on the quiz. Okay? Because if I give you like maybe 40 minutes, solve 30 problems, 30 questions, and I cannot uh, make sure, or I cannot confirm that you are really focused on that quiz, because maybe you can have sometimes to discuss with others, right? So I need to have a more robust. Oh, in the feedback quiz. Okay, okay. Probably I will increase maybe in 1 minute. Okay. Uh, yeah, maybe for the quiz, it's better not to have some each timer each question. For some students, it will cause panics. Yeah, so sorry for that. It will cause panics. Uh, my reason is because I want to have you focus and not have discussion with others. Yes, I will give you uh, the steps for the quizzes after Wednesday. Maybe Thursday or Friday, I will upload. Yeah, the timing. Yeah, so sorry if you feel that way. Okay, but we will have uh, offline quizzes as well. So I hope that will uh, give you more uh, flexibility in thinking. For the students who just joined the Google Classroom, uh, if you want to submit it, yeah, you can still submit it, but you will have maybe not full point. Okay, and you can leave the meeting if you want the online meeting. Okay, and for the students here also, if you finish, we can finish the class today. And thank you for joining us, and hopefully uh, you get benefit from my class. Okay? And hopefully for the international students, we can meet very soon. Okay, I think some of you are planning flights